Hey, welcome to a new episode of the SDV Coffee Talk. This is a very special episode because it's 1 year SDV Coffee Talk actually, and and
Congratulations.
thank you so much. And with my wonderful guests from my last episode, we talked about open source at SDV in our last episode, and now we want to continue because there are so many open topics. Yeah, just a disclaimer from my side. I mean, everything what I say here is my own opinion. I would say let's start a short introduction round. I would say, who wants to start?
Then I start. Hi, my name is Christian. I'm also known as Elfenpiff on GitHub, co-founder of Excite, and with Excite we push an open source IceRigs forward to have safety critical middleware for automotive mission critical systems. Thank you.
Hey, hi, I'm Matthias. I'm known as Elgo Berido on GitHub. Together with Christian, I founded Excite, and we are working since about 8 years on Eclipse IceRigs, and now IceRigs 2, which is rewritten in Rust, and we try to push the boundaries of what's technically possible forward.
Vinicius,
Go ahead, Philip. No, you go. You're next.
Then I'll do so because the connection anyway dropped. So I'm Philip. I'm working for ETAS, but I'm sharing my personal opinions today. So it's nothing related to ETAS or similar. It's my free time and my pleasure to take the second coffee talk here again. I'm in many different automotive OSS activities at home, so it's a pleasure to have this discussion. And Vinicius is hopefully back.
Yeah. Can you hear me? Yeah. So Vinicius here. Happy to be here again. Everything I say here is also my personal opinion. I'm working with open source already for a long time, contributing very low, trying to increase the amount of that I can contribute. I touched the Eclipse IceRigs before it was Eclipse IceRigs in the past, and yeah, that's it. Opinions are my own.
Cool. Thanks. I mean, in the last episode, we talked a lot of different approach about open source, how open source is shaping actually SDV and the ecosystem around. And probably this time we can start a little bit also with the topic which is enabling actually the whole ecosystem around the vehicle and also SDV that we have a proper environment where we build software, and how, for example, open source is supporting infrastructure. Actually, you need for SDV an infrastructure, and this infrastructure should be in a way that it supports the vehicle, the update management, everything properly. And we can probably start with this topic to look what kind of CI/CD, CT approaches are there, and just follow, then go to different other topics. What is actually the role of CI/CD and CT in the case of SDV?
Yeah, I think actually this is a quite interesting topic, because for me, open source is something like a philosophical question, because it's open for everyone. Everyone can contribute in the end, can have, let's say, great idea, and let's say bring this into an algorithm and put this into a repository. And for this, CI/CD is essential. And for SDVs, you have CI/CDs which are running on proprietary operating systems like VxWorks, QNX, and so on. We have also open source operating systems like ThreadX. And then you have also usually some kind of target board from NVIDIA to Qualcomm to Infineon to whatever. And this is something, for instance, which is not available for the standard open source contributor, which may be a student, for instance. Well, therefore, this is something, a challenge, which I did not yet see in any kind of open source project really tackled, that anyone can really contribute in some sense. So that you maybe have, you are a student, you want to just try out a repository which runs on whatever kind of vehicle, so that you can download an image on QEMU, you can just run an example, for instance, adjust the code, create a pull request, and say, here, I played around with this, I improved something, and here I give it back to you, and then you run your CI/CD pipeline. But here, the important point is you should also somehow be able to run it locally, so that you can contribute to this And this is something which is, in my opinion, currently missing.
I
something
mean,
which we
yeah, go ahead.
we didn't. So we did a little bit with the automotive work group within ELISA. So the example is 2 or 3 years old, but we tackled exactly this. And we said there are many different people who want to use whatever we do. Some may just want to have a binary. Others would like to build their own pipeline and so on. So what we were really doing is we had a GitLab CI, but of course then you can see the GitHub flow, right? The actions that you take. And we put it into a container, and you could decide either follow the step-by-step guide or go into the container, have the container image starting from there, cache the build or not, and so on. We put all this and documented this, and this really helped. And I had a freshest student, and they were able, so they had not touched GitHub before, so they just followed the steps, found some small issues, reported back to it, and said, oh, you need to swap this, and it's much better understandable. But I guess the core of it is that it's really the chance whenever you get all these prototyping things that you have a chance to reproduce it and that you really can build the things on your own. It may include that you have to download somewhere a binary or so, but you should not be stopped by any click-through licenses and so, because then it's not really continuous integration, right? You cannot continuously integrate things whenever you download an update and have to click manually on a click-through license, showing that you're an individual person.
But how this is, I mean, many discussions are usually on the ECU software, how open source can support actually ECU software, how there are Eclipse projects, other industry initiatives providing projects which can be used for implementing things in the vehicle. But the whole infrastructure is not really considered as far as I see. I don't see so much activities on that. That actually you need, if you have this open source project, you have to also the counterpart on the CI/CD that you can build, use this CI/CD infrastructure to build the software. Are there any? I mean, I'm not aware. Are there any projects supporting this?
No, but there are discussions as far as I know. I'd say we are also some partially part of this discussion. For instance, if you want to assume like Eclipse open source, for instance, you want to have a full stack open source, which is certifiable, for instance, you need also not only the CI/CD, but you need really the full package. You need use cases, you need requirements, and requirements have to be linked, and they need to be open. You need to see them, for instance. And this is something we are discussing, but it's a completely open topic, in my opinion.
Fatih, I want to bring another perspective. So when we talk about infrastructure, CI/CD, it can be a target build. They can be running on the target, or could be anything else. And there are so many things. And when I say anything else, could be a host build that you use to simulate some things and test your software to a certain extent. Of course, you need to go to the final target when you're going to release and certify that. So using that infrastructure, I think we are using in SDV widely open source technologies coming from old integration servers like Jenkins and so on, up to nowadays Renode, for instance, for emulating the SOC, the MCU, for instance. So Renode is widely used in Zephyr, for instance, so that you can, and we touched base on and Kemu also being also open source. So taking that angle from your question, open source is enabling SDV with those tools widely. And even there are things, I believe I mentioned that last episode, but if you have an open source project like Eclipse as ISORIX, and you want to use Coverity for static code analysis and trace the vulnerabilities and so on, Synopsys is, I'm not making any advertisement for Synopsys here, but Synopsys is enabling that for your open source project. So you can use that and you can get, so even if you go to Eclipse project, for instance, you're going to see the list of issues that Coverity is finding. And even if you want, you can try to fix it, right?
Okay. But there is, go ahead.
not just that is one perspective I want to bring. So there is and there is also the case of Sophie, where the intention is to leverage the close to the target. So you're not necessarily having the ECU in the server, but we are going to have a hardware with the same architecture, the same SoC or an ARM core there that you can compile and get the code running on it as close as possible to Qualcomm core or NVIDIA core, whatever you decide to put there. So that is also one thing happening in open source right now.
Okay. I mean, if I look on CI/CD, usually I look also on continuous deployment. I mean, this is a question which I have thought in the past a lot. I mean, we have a vehicle, we have a fleet of vehicles. I mean, this is some kind of a vehicle cloud, I call it. This is a vehicle cloud. It's connected. It's like the cloud we know, the classical clouds. Where you have servers, data center, and so on. And usually you use some orchestration tooling like Kubernetes to deploy container application on the cloud. But I mean, I don't see so much development in this direction if we, for example, consider vehicles. I mean, if you have the fleet of vehicles, this is some kind of a cloud also. But I don't see something like a Kubernetes to orchestrate container applications to deploy in vehicles. I mean, but this would be so cool if we would have this. Are there any projects or any ongoing work which goes in this direction?
Yes. Actually, it is a little bit a pity I cannot talk too much. I think last year, the Eclipse Open Source Summit thingy, OCX convention, I met a stealth startup from Ukraine, which are having exactly this vision, and they are currently looking for money to fund them. And they also wanted to create an Eclipse project out of this with an open core business strategy to exactly have this created. So therefore, there are people already looking at this problem and trying to
But if we, for example, take something like Kubernetes, I mean, this is not a certified tool. You have safety relevant parts in vehicle. I think the whole stuff has to be somehow also appropriate for safety relevant applications, I guess. And I'm not really sure if this is so easy, because usually applications you deploy on the cloud is not really safety relevant. But if you deploy things on a car, this will definitely be safety will be relevant. And I think I'm not really sure if certifications of such a tool like Kubernetes can be done easily. And also the containers we use, the container technology which is used must be also somehow suitable for safety relevant applications, I think. And I'm not really sure if we have already certain projects or efforts in this direction, because this is the future, in my opinion. I mean,
but actually, I think it's not so hard in the end. You have to distinguish between software which runs on the car and software which deploys software to the car in the end. And here you have to ensure with a tool qualification that the software is not altered, that you will say eject some raw code in there and so on. And this you can manage with certificates, for instance, and encryption. And I'm not here, let's say, I'm not too familiar with Kubernetes, but I think this can be tackled, that you can say, okay, I have here an insecure channel, I do not trust it, but via encryption and certificates, I ensure that the deployed software is not altered, and then you just deploy it to the car.
But this gives a new perspective on like the mixture of safety and security, right? I mean, if you have a security breach in the cloud environment and you have connectivity in SDVs, how can you trust what's happening in the like on data you receive, right? At least if you process it in a safety critical environment within the car. So I think the connection is very important, that you also, so it's not only end-to-end protection in your channel, but also like making sure that the integrity of the data is, as you mentioned, Christian, it's quite important element, I guess.
I think the deployment case, I mean, CI/CD, continuous integration, continuous development, probably it's easy to realized, but I think the continuous deployment will be much more challenging. I think it will be not so easy like in a classical cloud, because the vehicle cloud has much more requirements, I think, regarding safety, and this is probably this will take some time to enable such things on vehicles.
Yeah,
It would be so cool, I think. I mean, we have the same API, like just imagine you can use Kubernetes, so to say, to roll out an application in vehicles. This would be so cool. I mean.
But also continuous integration is not so trivial for open source project as for companies. So we had it before, the issues, and there's another issue. So if you are in a big company and have then I don't know, a few targets with QNX on the end user hardware and so on, then it's different for open source projects. So they have usually GitHub or GitLab, they have Linux on there. And even if they maybe have some emulator targets, it's still far from what you would have if you would run it at VM. And so scalability is definitely something, because then even if you were able to get all these targets running, the issue is then CI times become quite long, and especially for open source developers, if you want to attract them, they do not want to wait 5 hours until CI run is through and can merge some things or notice, oh, there's a small issue, and then you have to start it again from the beginning. So this is, one has to think maybe a little bit different than in corporations, where they didn't have something like Bazel and all of this other stuff, and they maybe are able to cache some things. But even for open source projects, I'm unaware of an open source project which comes really from the community, which has adopted Bazel. So they are still going either in Rust with Cargo or in C++ with CMake and so on, just because it's not fun and nobody really uses Bazel if they are not paid for it. And therefore, while it solves some of the issues, it's really, I think for open source projects, it's still an unsolved issue in the SDV area, how to scale things up in order to keep developer participating into the project when they are not employed.
But what do you think? What could be a proper solution for that? I mean,
when you talk about the deployment, if we call it CI/CD, it's continuous integration, continuous deployment. And I once read in the DevOps space where they said, if you cannot deploy it now, you're not doing continuous integration, continuous deployment, right? Yeah. And in the automotive industry, we're still talking, even in SDV time, sometimes about release. So we create a release and we will make another release in 3 months. Right? That's what we still hear also. Oh, we will have a major release and we have a minor release. A minor release come on a monthly base. And look at the open source components where releases just come. If they come and you may decide, okay, I have a major release. But if I have a major release for an open source component, it means I went through a qualification phase and where I make it mature. And I said, here was a fundamental breach or a major step or so. So it turns a major release from 1 to 2, 2 to 3, whatever. But the principles, the CI system and whatever, the main difference in many cases just the version tag which you at the end use, but the whole thing runs the same. So I can make a release whenever I want. And this is something which we need to get to, and where the tooling, the efforts we put in are crucial to keep this advantage. And this need to involve certification authorities also, because we are directly talking about mixed criticality and safety parts. So we need to have also certification authorities, assessors involved early in the phase where you develop, so that they also get the understanding of CI/CD, and that they say, okay, you have done all this gating in the tools that we actually have far less to check. And then it comes a lot to tool qualification, which we also touched before, where it's like that's where you have to look into and make sure the tools are not introducing any issues.
But as you told, I mean, if you for example say now, okay, we have this continuous deployment, I mean CI/CD delivery and deployment, and homologation must be part of this, right? I mean, automotive, this is quite important. I mean, certification from authorities and so on. I think then how this could look like. I mean, that these authorities provide some kind of quality gates. Are implemented, and if the quality gates are passed, then this is automatically certified, or how this could look like. I mean, such a certification.
I would actually say exactly like you stated. For instance, in ISO X2, we have, let's say, an unwritten rule limit, like everything which cannot be tested by CI is not a rule. If we have, let's say, a formatting check, like a coding rule and so on, at some points, we are not able to do this because, let's say, Clippy or, let's say, whatever tool you use, it doesn't yet support it, but in the end, you want to converge exactly into this direction. And also here's something which I saw here in the comments. Alfred Waugmann wrote that according to requirements, where he stated that they are IP of OEMs and suppliers, and therefore he's unsure if they would give them out of hand. But here I think also this is something which we also faced during discussions. But here sometimes I think that the OEMs are misguided and forget that they are selling cars and not middleware software. No one cares for that. I really would like to hope that some customer comes to BMW and says, I can buy now the new BMW because ISO X2 is running in there. I'm pretty sure this will not happen soon.
There are many aspects on this. Yeah. So the angle that I see this is how can we decouple, and that is if you look at the continuous delivery book. It is going to tell you that the first thing you need to do is to decouple the releases, the real releases, from your development process, right? So you're going to develop, have the continuous integration, etc., and you move from a pull, from a pull mechanism to a push. So you leave that there, right? So from pull to push, and the release is going to be available, and the artifacts are going to be available. If you wanna go and use that, it's your problem. You use it. So that is one thing that's how I see CD for automotive, because I don't want to be involved in the discussions about may I release my autopilot here now or not because of political issues. And we are today all in Germany. So maybe Tesla is not in a good shape to be releasing autopilot here nowadays. The political issues, I don't know. Who am I to say that? But we are technical guys. So how can we decouple that? And the way I see is that we make the software available. The point that was raised, it was Alfred. The requirements, looking from other angle, the requirements, they need to be part of this environment where I'm certifying, whether they are proprietary from OEM or open source, doesn't matter. They need to be there as one artifact, as important as the code, as important as the binary. Those are going to be artifacts. And once you can reach the stage that all those artifacts are there, every commit, every release you do, so every commit, then you are in a chance to have a release out of it, and the tests are passing also. You have the test report, so all your artifacts are there. This is how I see the CD. I know the CD in IT environment and cloud environment has a whole other perspective of releasing that into the field, rolling back that fast if something goes wrong, etc. With vehicles, we cannot do that. So that, for that reason, have the release ready. And if someone needs to use that, they're going to pick it and they're going to use it. And this is, and you test, of course, on the target, in the final target, ideally also in the vehicle when you're testing. So this is how I would decouple. And the point from Christian regarding this is where I see, I don't see like OEMs open sourcing their core technology about the best ACC feature in the world and so on. What we should focus on open sourcing is things that are kind of commodity or not commodity, but that are not differentiating the car at the end of the day.
And this then also circle around to the requirements question from Alfred, because non-differentiating topics, ideas, requirements are the things which you can share. And I can say that it works because I've spent about 15 years, not exactly, but 10 plus years in a joint venture of Bosch and Denso. I mean, they are the biggest competitors, and they just said, like, let's build a common software base platform for our in-vehicle systems. And they gave the requirements to this joint venture we've been in, and we were just looking at and making it in this way just neutral, that would remove customer information and so on, because they were just the tiers. But there were so much things which you can just bring in, and they gave us the requirements because they knew that they are non-differentiating. That's why they made this joint venture. And I believe that's the thing. If you have an open source environment and you say, this is something which I see as non-differentiating, nothing should hold you back from providing your requirements on it.
There is one interesting question I've seen from Martin. He's actually a former student of mine. Hey, Martin. He's asking, this is a very interesting question, actually. I mean, he's asking about the AI-generated code and open source projects. I mean, I can remember that GitHub was claiming that, I don't know, 50% of the code currently on GitHub is created by AI. And this is also, I guess, on all sectors, you know, open source project from different sectors. And the problem in the context of SDV is that automatic created code could have a lot of problems regarding security and safety. And if open source project uses this massively, how to deal with that, actually?
I would say you shouldn't do this. I'd say I did an experiment. I wanted to write a C example with Gen AI just to see how it works. And then were these teeny tiny mistakes which also slip the human eye. There was a null pointer check, but instead of checking that it's not null, it checked that it's null. And then it passed, and then it segfaulted constantly. And it was hidden behind 200 lines of code, and I just didn't see it. I had to debug into the code. And because AI does not understand, AI is perfect for instance, we use it for an early review to catch, say, mistakes, let's say spelling mistakes and so on, or where you have maybe coding which you could apply these simple things in the end. But when it comes to understanding, these LLMs do not understand. They just, let's say, provide right what you gave a prompt, you gave a question in the end, and they answer with the best fitting one from a likelihood perspective, not from an understanding perspective. So therefore, they are perfect for, let's say, getting to know the code better, to get into the matter, for instance, to do some kind of, let's say, improved research on the code. But when it comes to actually design and write the code, I would not do this.
But
we should experiment with this, but I would not do this.
But there are many projects like Eclipse Cuxa, Velocitas, and now recently OpenSOVD. I mean, these projects are contribution from many people, and these people probably use such tools and also generate code and commit this code. And this can bring some kind of security holes into the whole project. I don't know how to deal with this thing if the code generation becomes more and more popular and the amount of code is immense. I mean, if you generate a lot of code, it will be also not easy to review by human.
Should that make a difference?
The thing is, it can. I mean, maybe it's a multiple dimensional perspective, because it means just because we cannot do it now, it doesn't mean that we cannot do it in a year from now or two. Because the language models are evolving rapidly. A very strong impact that the second one is that we got server outage on open source hosted repositories because the traffic was so high that because for the training data where they were scanning and causing so much traffic and also doing requests by searches, that this was causing issues. And one specifically, but this is an Eclipse SDV thing, but it was going, because you just pointed to it, it's that Eclipse SDV in the committer guidelines actually said that you have to indicate when you commit AI-generated code.
Okay.
I'm pretty sure not everybody will follow it.
Okay.
And it's a question also how much, but I mean, you can say, okay, I have 5 lines of code and I checked them and they were AI supported. then it may be something different than what Christian says, like 100, 200 lines.
Exactly.
That's something where things come in. But also a lot of committers may. It really depends. If you're just a contributor, you will make small chunks maybe, or you get a review instance. But if you are the committer of a project, then you need to make sure you have the testing in place, that you do the things, that there's maybe another committer. And this is with the size of the community. If there's a single maintainer writing a lot of things with AI,
exactly, yes.
then today there's maybe a strong. But the question is, will this committer who had this project before really use so much of AI? Or would he not anyway say, like Christian said, well, I'm writing this and I know it and I tried on, and if I had so much pain in debugging, the next time I will write it on my own. And I'm not a good programmer, but I decided quite often already to switch off Copilot because I hate these suggestions which he did, or it did, because just said like, do it like this, and it's like, no, that's wrong. The change, I think it was trained for the things I was doing.
Yeah. So one thing is, like also Vinicius said, so there will be code contributions on one side, and it doesn't matter if it's AI generated or if it's a junior dev. So you have to review it, you have to check it, you have to be careful and so on. Therefore, you also have to have the CI with high test coverage and so on. That will catch some things, but you also, if you do not know the person and if it's a new contributor, you really have to be careful with reviewing, and then it really doesn't matter if it's AI generated or not. The question is what to do once you notice that it's AI generated. And I know a lot of open source projects where they say no AI generated code, because also what the other guys here is that it's just not quality code. So and there are also multiple blog posts in there were stating, hey, if AI is so good at coding, why is open source not using it? Because that would be a perfect fit. But it's just, it's not there yet. It just makes adds an additional amount of work and so on. And therefore, I also think for us, since where we are working, especially with IceRigs, it's at a low level and there's not that much code that AI can be trained with. And therefore, especially for us, it doesn't make sense to accept any AI contributions. It will be, full of bugs and so on. It's different if you have something where there's really a ton of data to train the AI, for example, website generation and so on. There it might be different. So it also depends on which layer you are, how much data is available, and at each layer the decision might be different.
And one little thing to make up your mind on, I mean, if we're talking now about professional open source parts, but we have a lot of hobbyists also, and they will make use of a lot of auto-generated code. These are maybe fresh programmers, and they put this into repositories, and maybe someone picks something up there. I'm not talking about a product here. Where I want to lead to is like this will be the training data for the next models, right? So you train data with the generated code, which was not good in the beginning, where during the training they assume it's good. And we actually had this during our last workshop. I made a presentation and I put in some safety things on the ELISA scope and put on the slides just like what the AI proposed. And we were laughing about it to some extent. But then as we said, we should not publish these slides, because how do we want to make sure that this language model, I now have a very red strong disclaimer in there. It's like misconceptions of AI on what safety is. And I hope that by this, it's strong enough that the AI will not pick it up as like, I browse for it, search for it, and what is Elisa saying about this? And then I get my made up AI things later on. But it's still a great help.
In this context, I think automatic checks of the code through tooling becomes more and more important. I think. That you have some kind of a static code analysis with certain things and so on. I think this will become in this age much more important, because AI generated code can be very harmful in the vehicle.
But it can also be of great help.
Yeah,
it could be also great help. Yes.
So I see this. I think there's no way back.
I think it's also like how you use it, how you use the tool, right?
Yeah, I think there's no way back. So it is going to be there.
Yeah. We have to deal with that. We have to deal.
You need to deal with that. And then my question, and what Matthias said, my question is, why should that be different? I mean, if you have someone programming very badly in your team, what would you do? You would teach this person. You would go and review the code. So I think that if you have a process, if you have a single person project, yeah, that is okay. But then are you going to use a single project, the single person project into your product? Then shame on you, right? That is one criteria that I use to evaluate my open source project. The open source project I'm going to use, is it well maintained? Do we have Matthias and Christian maintaining it, or do we have some hacker somewhere maintaining it, or whereby hackers can write good code? But do you have someone crazy writing code using AI like me, or you know, I don't know. So if you have a process, and that's where that would lead to a completely different discussion, and I think you touched base on that. But ASPICE and other processes that exist, they are helping you to look at things that you might not look at, and also the community, the way the community curate the code, the way that okay, Linus, maybe he's sometimes too heavy, too pushy on the way he does when I'm to say something about that, but he's curating the code that got in. So I'm pretty sure that Christian and Matthias will take care if I make a contribution to Eclipse ISORix. They are going to look that the best is coming out of the contribution, and not, and the process shouldn't be different. If someone is going with AI, it should pass the same code, and the quality code and the tests, everything should go. So that is
yeah. But the thing is, if you're a developer, I think we all know software development, and you have a code, you have dependencies, thousands of libraries, somewhere your dependency management is handling. You don't check every dependency, actually, how it was developed, how many maintainers exist. You just use it, just use the dependency without checking the background, who's maintaining this, who's committing on that, and so. I think this is this dependency with many open source projects can be a problem. I don't know how to, especially in this AI generated, or in AI governed environment at the moment. In automotive, in my opinion, this can be some kind of a problem because of security, which can lead to safety problems. And I don't know how to handle this complexity, actually.
Actually, it's like we did or do is like reduce the dependencies we have as drastically as we can, for instance, the one thing. But actually, this is not a long-term sustainable, but you want to include other projects, for instance. And here, this would be actually a perfect opportunity, let's say, to also increase innovation. For instance, when you say we depend on whatever grade, for instance, Serle is a very popular Rust grade, for instance, we also depend on this. This is not yet certified for ASIL-D, as far as I know. But for instance, if now some automotive customers come and say, okay, we are using, let's say, this software, and all of our softwares have dependencies to Serle, for instance, let's contact the developers, support them with money, for instance, and then you also help them certify this, and let's say also bring a process to this grade. And what they also gain is quality from it in the end. When they follow this process, and it's, let's say, a well-maintained one, which is also reasonable, then you have the opportunity for you as a developer for your grade that you can now say, okay, my grade is so safe, it also runs in space, for instance, which is quite nice. And you as an automotive customer, for instance, or as an automotive user, you have now a dependency which you do not have to care anymore. If you have, let's say, something like this, and we have, let's say, these, let's say, qualifications already on the business level, like with ISO 9001 and so on. So therefore, why not bring it up to the next level?
Yeah. So normally dependency is controlled, right? So if you're talking about embedded software in big corporations, so they are well controlled, and there are commercial tools like Black Duck, but there are tools also that are like within Yocto, you get a full software bomb, we call it. And you have the list of software that you have there. And I do recommend following a guideline on how you choose the open source you're going to use, because if you don't do that, then you are going to end up having bad quality code in your product, which could be any product. So we are talking about safety critical, but I use these guidelines even for smart TVs in the past. So we would be curating very well what we choose to put inside the TV. Because quality was important for us, even though we would not kill anyone if the TV stopped working. So this is what I think is very important. And then you have, again, tools like Coverity and so on, which is going to show you the vulnerabilities of that code. You can rely on it as well. So
I had some discussions in the last couple of weeks, and people bring exactly this argumentation to say no, open source is not appropriate actually, because you don't know how the project is maintained, what is inside, what's the dependency. It's better to go with the company which provides some solution, because we know this company is maintaining this. This is exactly I brought this topic because of this discussion I had already. And it's not so easy, I mean, to argue against.
Yeah, but
you
the company can go broke.
Yeah. And also, it's sometimes we have also open source projects like Qt, for instance, which are backed up by a company, or like Isorix, which is also backed up by a company. So therefore, but I think this is an absolutely valid reason. Sometimes we have a beautiful open source project where I say it would completely fit my use case, but the poor developer has a burnout, and you have an issue and you need help, and you cannot contact him because he has other things to do, like family.
Yeah, but if it comes that far, then quite a lot has gone wrong before that. Because if you use open source, we had it the last time. It's not like free beer; it's like free puppy. So you have to take care of it. So
definitely.
It doesn't matter if it's open source or if it's closed source. It's a risk to use it. With closed source, like I said before, the company can go broke, and then you do not even have the code. With open source, it's in your hand to support the open source developer in order that the developers can continue working on their project. And it's just a fraction of money they would have to spend on this in order to keep the ecosystem healthy. But the issue is, we also discussed it the last time, that quite a lot of companies are thinking open source is free labor, and with this mentality, they might end up in such situations that they rely on open source software, and then the maintainer is burned out, and then they have a problem. But then they did quite a long wrong in the first place.
Yeah, and if I have a distributor, and if I contract a distributor who guarantees me service and who will also provide patches to open source projects where I cannot reach out to the maintainer directly or so, I mean, that's a valid use case, and it's a good use case, right? And that's exactly what you're saying, which is it's this step from I just consuming it to, okay, I can buy a completely proprietary tool, or I can have a selection of vendor who provide me support on an open tool where I even may have later on the chance to change to another solution, keeping my software. And like taking your software with you to another vendor is something which is enabled by an open source thing. It's not, of course, not a one-on-one thing. And it always has a little bit of hiccups in a way of changing, right? But you have the chance. And in an SBOM, you can have the chance to see how good is a company. And now comes the AI trick. You can, I mean, I was thrown out of this coffee talk for a minute or two, so I don't know what was discussed, but you can just say, like, when now everyone has to deliver the SBOMs and we see how the stacks are created and what's in there as licenses, we can actually throw an AI on it and say, provide me a first overview of like, what are the critical libraries? And we are in this perspective and say, oh, see, we are all using this. Let's bring it in. Yeah.
Look at this. This is one case, for example. I mean, when companies use closed source solutions, they always have contracts that say if the company goes bankrupt, they get the source code. This is also an argument I've heard.
I would here counter the argument and say the source code tells you how something was implemented, but not the why. And the why is more important because you get the source code, but it does not say that you get the developers who wrote the source code, who know how to maintain it, who know all these little details about this. And if it's not like a website, but a more complex system, like operating system or something like this, you will have, you have the source code, but in the end, when you have to do tiny adjustments, it's nearly impossible to find it the right spot there. This is, yes, it makes things a little bit easier, but you still have problems.
But in the end, this also means that the question is irrelevant because if the open source project is unmaintained and you have the source code, or if the company is bankrupt and you get the source code, it doesn't matter.
It's more or less the same, But this discussion I often face, this discussion, there are people pro, cons, and people say, open source, but the company is better, and so on. I mean, I face very often this discussion, and therefore I just wanted to have this here also. I would like to just ask one question, which also keeps me busy. I mean, do we already see in automotive nowadays, in this SDV context also, that open source brings already some benefit in different, OEMs or so? Do we see this already? For example, we have a lot of open source projects which are available for automotive. I mean, Eclipse. You can find many projects there. Do we see already some benefits for the companies, for the car makers, so to say, already using open source? This is not clear to me.
For me, before you go deep, you answered that with your first question today when you asked about infrastructure. I don't know any OEM which is not using open source solutions for for their build tool chain, for their continuous integration servers, test environment. So yes, a lot of benefits. Now we can go deeper on other topics.
My point was, I mean, you see these projects like Coxa or other, Open SOVD or so, which is directly running in the vehicle, I mean, which is directly there, not the infrastructure part. For infrastructure, for sure. For sure. But do we see, I mean, already some benefits OEMs has from this open source projects? I mean, time-wise or, financially or so. I don't know. This is something I cannot really.
There are. Here one example. Let's assume you are an OEM and you need a tier 1 to write to some software, for instance. Now we have two options. You have a complete closed source ecosystem, and now the tier 1 has to buy the license, and now you have to write a requirements document, and you have to specify, you have to make this, and this. This is the usual adaptive AUTOSAR or AUTOSAR way. Or you can say, we have here this open source project. We have our unit tests, which are open source. Unit tests are read now. These are our specification, for instance. You implement now the feature, and when the feature is finished, our open source unit tests are green. You use our open source software, which we have provided here. We have a very clear contract, for instance, and here the tier 1 has no longer the license costs, which you have then to pay for via the tier 1, for instance, and you have a completely different open way of working together. Something which makes the administrative costs and overhead, it reduces it massively, and we already see this in the context of ISOX. Another thing is, for instance, which you see if you broaden the scope a little bit and say you do not only look at vehicles, but we just look, for instance, when you have a successful open source project, you maybe reach the point that not only your automotive customers are using it, but also other industries are using it, and they have other use cases, other problems. You may also have, but you do not have solutions for, but they have already a solution for it for 20 years, for instance, and then you can enrich each other. This is also something which we see, for instance. One very practical use case is medical devices, for instance. They also have to be certified, also quite harshly, not as harsh as ESLD, but it's getting near to this. But they have some different approaches, for instance, like how they test their codes, their components, for instance. And this is something where open source, again, brings different industries together, and you do not have to solve every time the same problem. So once for automotive, the same problem, once for trains, once for planes, once for medical devices. But you bring the people together and say, here's the problem, and then also, oh, okay, I had the same problem. Let's bring the solution together. And this is something which open source enables you massively. When you have a closed source ecosystem, you do not have this exchange in knowledge and experience. You go to a conference and then you are, say, an employee from company X and talk to someone from company Y, but it's IP, you have an NDA, you are not allowed to talk about this in a general picture, yes, but but with open source, you can just say, okay, we have here this thing there, just check it out. Here's a solution or here's a demo for how we tackle this. And then you bring the people together. And this is something which I also on a personal level really enjoy, that, for instance, with Isorix, we have brought together high-frequency traders, which we never thought of, in the medical industries and simulation games and so on. And they all want to have different aspects of the thing, but they enrich each other. For instance, a high-frequency trader wants to speed overall. They don't care for stability, but they get stability because the automotive customer wants to have stability and reliability, but it's not bad for them. It's just a cherry on top. And the same thing is for the automotive customer. For them, it's a cherry on top that it's a little bit more efficient, for instance. They do not absolutely require this. Here, safety is more important, and this is something I think when you have a proprietary product, it's extremely hard to, nearly impossible to achieve the same exchange in innovation you have in such an ecosystem.
And I guess if you have, like, as you say, and you brought up the medical thing, and recently people come up with Zephyr in automotive, putting it on microcontroller or even on microprocessors. They ask for the certification pass on it. In medical, they are already used, and as you said, it's relaxed standards to some extent. They have software of unknown pedigree, so SOUP, which is accepted in there, and they bring in things. But what you really benefit of is, like, and Vinicius, you were pointing it with Renode. You have, like on Renode, you can see how many things are tested, how many boards are there. You can have a vivid community and protocol. So if you have your one generation, you're building like 100 devices and you want to build the next one, you figure out your chipset is no longer available or there's a cheaper board. You can take the whole thing and just simply port it. And we see, like, in the past experience, that things which took us months in the past and bringing up due to the experience which we gained in the software technology stack which we're using, it could take it to weeks, in best case sometimes days. And a colleague of mine just took a middleware stack. I don't name anything there, and I don't name from where to what he did, but he said he got a new board, he took a QAMware simulation and then the software part, just brought it in there in less than a day, and he said, well, it was just working because I understood the technology, I had the background, and I just took it from the open. And the only thing which I need is the POSIX interface. That's
I think there are also some points. Maybe you can touch base on that, Philip. But Fadi brought that on the chat. So regarding Linux, AGL, Virt.io, and vSUMIP, what he says is a bad example being used in in-vehicle in production. So that's true. I think Linux. You mentioned that, right, Philip? So you are actively contributing to AGL, but even before that, maybe Linux is already running on the vehicle, right?
Yeah, and also so in various use cases. So we did this step from a proprietary part because we needed the performance and everything, and we're not successful like 12 years back. And this is actually, but I think that's also good, and that's also where things show, because these were all, like, also with the Android, we know that's like this, and AGL, for example, just came up with their SDV expert group, which is currently building up exactly a system like Fadi is writing it. There's Virt.io involved there. There was, I can even look for the slides later, maybe put in the chat. I was on the last ELISA workshop where Kusakabe-san from Honda was presenting this and say, we would like to do more in this field and bring this up and have an open SDV ecosystem. And as said, vSUMIP may be bad, but let's start with this and challenge it and look for new things and see what we're doing with it. And that's a good point.
Can we, if we look on the current landscape on OEMs, Asia, Europe, US, can we say that open source has a significant contribution to the China speed, so to say?
Yes.
That China is developing so fast. Is it? Can we say this? I don't know. I'm just asking.
It's one factor, I would say. Yes. Yeah, I think it's one positive factor. You saw HoloOS from Li Auto. They are using Node-X. It doesn't. I'm not saying it is a perfect stack or whatever. There are missing parts, and they are also kind of somehow they are also working with AutoSAR. And I heard that even many Chinese OEMs are doing great work using AutoSAR Classic. So that's the reason I don't think it's the only thing, but I think it contributes.
Okay.
Yeah, definitely. So, of course, it helps if you already have some software that fits into the car. One thing is also they don't have all this legacy. So for them, it's easier to just take what's there in open source and then build up on that. But I think without the open source code there, they would not be as far as they are now. And the third thing is also, as far as I know in China, when people switch companies, they just take the code with them and it's allowed, more or less. So they can just more or less take the code, and it's an evolutionary process. If someone from BYD goes to Li and takes the software with them, and then, hey, this is better, they just use it and so on, then it goes back to BYD. And therefore, it's more or less like open source within the companies.
Okay.
You can also take it to other direction. I mean, it's really, these are new, comparably new OEMs, and they have not the legacy, as you say. And it's not only China. I just got approached by a Brazilian transportation as service startup who said, we are building everything. We built the whole vehicle and we're responsible for the software. But we have the chance now that we don't need to use any legacy. And they just dropped me a message like, what's your view on it? How do you see things? What should we take? What should we consider further? And you can just see like they can make these decisions where it's very hard for us in a settled environment of the European OEMs and US American OEMs who really have a long history and a long good quality thing and paved ways where we are in. And that's where in China there's, even if it's East, it's like the Wild West of the car industry, right? And currently they have 100 plus companies which are competing, and they will shrink down to most likely 7 to 10 major OEMs, and then most likely over the time they will also get a little more inflexible in the way. I don't know if they will keep their culture forever when it comes to lawsuits and so on.
Yeah, let's see. I mean, in discussions, I have some trouble, for example, to convince people that open source is an advantage because of all this stuff I already talked about. I mean, it would be quite interesting to measure this. If this would be possible to measure, so to say, objectively, what open source brings to the OEMs if they go with this approach. Compared to the closed source, but I don't know how to do that actually. I mean, if this could be measured at all, but
actually, this is something also which we tackled a little bit. What we wanted to do is to attach a money value to ISORIX2, for instance, and then we did just see like the idea was if you would remove all the source code, everything completely, and we would rewrite everything from scratch. How long would it take us to rewrite the same features? Okay, it would be, let's say, 6 people, maybe 3-4 years until we reach the same point. Well, therefore, if you have an open source project which you depend on, like, let's say you depend on ISORIX2, and you would not choose to use ISORIX2, so therefore you would require at least a team of 6 people for 2 to 3 years, or up to 4 years, until you have, let's say, implemented this stuff on your own. But here you need more. You do not only need the money, you need also the right people. Maybe you have intelligent, smart people which cannot stand each other. Therefore, your project will be a failure. Or maybe you have people which love each other, but they are not competent enough, or whatever, for whatever reason. Or so this is something where you can put a real money value on this. And this is something for a lot of these open source projects. So therefore, how to measure this is just imagine how much time you would invest if you have to write this on your own. Completely, and this is it. Then you get a real money value out of it. And these are, I think, for the basic stuff in the CI/CD pipeline, I think there are multiple millions or maybe hundreds of millions which you benefit from it. But in the end, the thing is, it's like a little bit invisible. It's you do not see it until for whatever reason, some kind of thing would happen and you would not be able to use the software anymore, and then you have to write it on your own, and then you would suddenly see, oh my God, this is so expensive. Why didn't we do this or invest time?
And it's
damn, we are running out of time, and I have so many questions still. I mean, it's already 1 hour is gone, and I don't know where. When. That's
one thing. It's a coffee talk, but no one has a coffee cup. Except
I have
me.
a coffee cup.
Oh, okay.
Today, exceptionally, I don't have. I just have a cup of coffee. It's empty, so I need to get more.
We have to really think about a follow-up. I don't know, next month or the months after. I think I need more conversation with you guys.
It's always great.
I mean, we already at the end of the stream. Do you have anything you want to say as last word?
I want to see your t-shirts.
I had one last statement. I don't know if it's a good one or not.
Finish, go ahead.
So statement which I want, it's maybe not simply about open source or proprietary, because open source is not the value in itself. It's about the ecosystem around, about the people, the adoption rate, and so on. And this makes it, and you can achieve this in various kind of forms and industries, and there may be good reasons to choose proprietary, and there may be good reasons to choose open source. And the biggest mistake you can make is just promote open source because you have to do open source. You need to understand why you have to do open source.
Exactly. Yes, exactly. Yeah.
And maybe one point we touched also last time, continuation. We touched it today as well. So if you can continue with a technology, even if the supplier is not the best supplier and so on, that is one kind of invisible benefit that you can get out of open source as well. So, and this is hard to measure as well. And
also, let me say also one thing. I think it's actually happiness. You as a developer, if you are an open source developer and you see another developer just say, cool stuff you did here, you enabled me to do this project. This is extremely rewarding, and
I think so. Yeah,
it's really personally, it makes me really happy. It's
one thought, one food for thought as OEMs and the automotive industry is already for a long time using open source software. The key question is, do we really want to contribute to open source? And if yes, why? And this is a difficult question that I also need to answer many times. So what is the benefit for my OEM, my tier one, my whatever? What is the benefit out of it? And this is...
Vinicius, I think this is a perfect topic for the next episode. To convince, so to say, OEMs why they should contribute to open source projects. I mean, I think, thank you so much for your... for this nice talk, see you hopefully soon in the next episode. See you. Bye.
Thank you. Bye.